Hi, in this video I will explain the rules for naming alkenes. In naming alkenes, first of all we have to choose the chain of carbon atoms, the longest chain of carbon atoms that include the double bond, and name it by adding the suffix "-ene" to the name. For example, in this case here, this is going to be the longest chain of carbon atoms, and this is hexene, so it should include a double bond. If we choose this chain, which is 1, 2, 3, 4, 5, then we will just have 5 carbons. Whereas this one, which is highlighted in yellow here, has 6 carbons, so this is the correct one. The second rule is that when assigning numbers, the double bond should be given the smallest possible number. That's why we have to count from the side which is closest to the double bond. So for example, in this case here, again, this is the longest chain, so this is 1, 2, 3, 4, 5, 6. So this is hexene. And when I want to assign the number for this double bond, I will start counting from the left side, because in this case the double bond will be at position 1. Whereas counting from the right side will assign number 5 to the double bond, which is not what we want. So now again, 1, 2, 3, 4. Now we have a methyl group at position 4. So this is 4 methyl, 1 hexene. Let's take another example now. So the longest chain is 1, 2, 3, 4, 5, 6, 7. So that's heptene. Definitely the double bond is closer to the left side. That's why I will start counting from the left side. 1, 2, 3, 4, 5, 6, 7. So the double bond is at position 2. That's 2 heptene. And then we have a methyl group at position 2, and we have an ethyl group at position 5. So according to alphabetical order, ethyl goes first, and then 2 methyl, 2 heptene. One more example. So 1, 2, 3, 4, 5, 6, 7. Again, this is heptene. If I started counting from the left side, the double bond will be at position 3. Whereas if I start counting from the right side, the double bond will be at position 4. So again, we are going to choose the smallest number. So we will start from the left side, and this is 3 heptene. We have branches again at positions 3, 5, and 6. 3 is for the ethyl group. And then we have 5 and 6 dimethyl. So this is going to be the name for this compound. One more example here. Now here you have to pay attention. Someone might choose this to be the longest chain. However, this doesn't include the double bond. So the double bond is outside this chain. That's why this is not going to be the correct longest chain. Your longest chain should include a double bond. That's why I will start from here. 1, 2, 3, 4, 5, 6, 7. So that's heptene again. The double bond is definitely at position 1. So that's 1 heptene. And then we have at position 2, we have a propyl group. At position 3, we have an ethyl group. And at position 5, we have a methyl group. We have to write them in alphabetical order. So ethyl goes first. So 3 ethyl. And then M, so 5 methyl. And then we have 2 propyl, 1 heptene. So always make sure to choose longest chain including the double bond, and also make sure to always give the double bond the smallest possible number. Now, if you ended up with 2 chains including the double bond that have the same length, then you have to choose the one with more branches. For example, in this case here, I can choose this one to be the longest chain, 1, 2, 3, 4, 5, or I can choose this one, 1, 2, 3, 4, 5. Now both chains have the same length. 5 carbons, and they both include the double bond. Which one should I choose? I should choose the one which has more branches. So if I choose this chain, I'm going to end up with 2 branches, which are the isopropyl and the methyl group. If I choose the other one, I'm going to redraw a structure here just to clarify. If I choose this to be the longest chain, then I will have 1, 2, 3 branches. The correct one is actually this one. Choose the one with more branches. That's why. So the longest chain will be this one here. So we have 5 carbons, so that's pentene. Again, the double bond should be given the smallest possible number. Counting from this side here will assign the double bond position 2. From the other side it will be 3, so definitely that's 2. That's 2 pentene. And then we have a methyl at group position 2, an ethyl at position 3, and another methyl at position 4. So the order will be 3 ethyl, and then we have 2, 4 di methyl 2 pentene. So those are the 2 possibilities. If we choose the red one, which is the incorrect one, you will end up with 2 branches only. Whereas if you choose the black one, you are going to end up with 3 branches, which is the correct way for naming this compound. If numbering from both sides assigns the same number to the double bond, in this case you have to start from the side which assigns the branches the smallest possible number. But again, this is only used if you are ending up with the same position for the double bond from both sides. So for example, in this case here, 1, 2, 3, 4, 5, 6, 7, 8. So that's octene. Now, if I start counting from the left side, my double bond will be at position 4. And if I start counting from the right side, my double bond will be also at position 4. So it doesn't really matter with respect to the double bond whether we are going to start from the left or right side. So this is for octene for sure. However, if I start counting from the left side, the branches will be at position 3 and 5. Counting from the right side, the branches will be at position 4 and 6. So definitely we have to choose the smaller numbers. That's why we will choose those 2. So counting from the left side, and again this is 5 ethyl according to alphabetical order, 3 methyl, 4 octene. So always, if you are ending up with the same number, same position for the double bond, start counting from the side which is closer to the first branch, or which gives the branches the smallest possible numbers. If we ended up again with the same numbers even for the branches, in this case we use the alphabetical order rule. We always use this one. You can use this one, which is MBA. So first of all, the priority is for the double bond, and later on you will see it's for the triple bond. And then the priority is for giving the branches the smallest possible numbers. If we ended up with the same numbers, then we use the alphabetical order rule. That is how we can remember this one. For example here, 1, 2, 3, 4, 5, 6. So this is the longest chain. This is hexene. Counting from the left or right side, your double bond will be at position 3. So this is 3. With respect to the branches, starting from the left side, 3, 4. Starting from the right side, also 3, 4. So we are ending up with the same numbers. In this case, since we have the same numbers, we have to use the alphabetical order rule, which is the group which is written first according to alphabetical order should be given the smallest possible number. That's why ethyl goes first, and that's why it gets a smaller number. So 3 ethyl, 4 methyl, 3 hexane.